Good morning and welcome to my channel. Today we're going to be looking at the Maker Advent Calendar from the PiHut, the 12 projects of Codemas. So what we're going to do is we're going to go and visit this URL here, the pihut.com/advent. Okay, so this page includes links to each day's guide for the Maker Advent Calendar, which include component details, wiring guides and diagrams, example MicroPython code, and many examples on how to combine components from different days. We also include a calendar content section at the end of this page for those looking to understand what is included in the calendar before making a purchase. Well, we've already made a purchase, so let's dig straight in to day number 1. So click on day number 1, and then I'll get day number 1, box number 1 for day number 1 out of the calendar. So this is what it looks like. We have 12 projects, 12 boxes, numbered 1 to 12. So I'm going to start with getting that top one out. Here we have it, box number 1. So let's have a look what's in it. So we've got a USB cable, so USB to micro USB cable. We have a breadboard, and we have a Raspberry Pi Pico H. Let me get this out of its box. Let's take a look. Quite tiny. Here we have it, the Pico H. Get it in zoom. Tiny little board. This is what we call a microcontroller. Okay, so let's have a look. Okay, welcome to the first day of your 12 Projects of Codemas Advent Calendar. Day 1, getting started. You'll have already noticed that the first box is larger than most of the others. This is to give everything you need to build the foundations for the fun projects you'll be making over the next 12 days. Box number 1, contents. Like we've just gone through, we have a Raspberry Pi Pico H, a 1 meter micro USB cable, and a 400-point solderless breadboard. So today's project, we're going to get you set up and familiar with the Raspberry Pi Pico, including installing the software required to program the board, as well as running a couple of very easy projects to get to grips with MicroPython. So the Raspberry Pi Pico is a powerful, flexible microcontroller board from, you guessed it, Raspberry Pi, the same folks who brought us the Raspberry Pi 4 and the Raspberry Pi Zero. The Raspberry Pi Pico is a different kind of Raspberry Pi though. It's a microcontroller board, not a microcomputer. The brain of the Pico is an RP2040 microcontroller chip, the little black square in the middle. Whereas you might use a Raspberry Pi 4 to play games, write stories, and browse the web, the Raspberry Pi Pico is designed for physical computing projects, where it can control components such as LEDs, buttons, sensors, motors, and even other microcontrollers. The board has lots of pins around it called GPIO, general purpose input-output pins, which allow you to connect all sorts of components to make projects. These are controlled by code that you write. A map of the Pico's pins are available here. So let's click on that link and let's have a look. Oh yeah, that's pretty cool. Just going to zoom in on that. Get that a bit more centralized for you. There we go. There are all the pins on the Raspberry Pi Pico. The Pico can use many different programming languages. However, the most popular is MicroPython, which is what we'll be using over the next 12 days. The board has a micro USB port on it here, which gives it power and allows it to communicate to our computer for programming. There's a lot more to this little board, but we'll keep to the basics for now. So we're going to install software called Thonny, which will allow us to program the Pico with MicroPython. MicroPython is a smaller, more efficient version of Python 3 programming language designed to be used with microcontroller boards such as the Raspberry Pi Pico. If you've programmed with Python previously, MicroPython will feel very familiar, but don't worry, we're going to guide you every step of the way over the next 12 days. Thonny is a Python IDE. An IDE is an integrated development environment. IDEs help us to write code by giving us lots of helpful features to avoid errors, make our code more readable, and lots of other benefits. So let's get Thonny. Head over to thonny.org and look for this little box. So let's click on here. And we're looking for this little box here. We're looking for, I'm on a Windows platform, 64-bit version. So I'll click that, download it here, and click install. Okay, so if you hover over the system that you're using, Windows, you should see some options. Download your option, Windows, Mac, or Linux. Thonny installs like most programs and will ask you to accept the license agreement and confirm when to install it. We kept all the options as default and it took just under a minute to install. Once installed, select Finish and then open the program. Okay, let's have a look. Welcome to using Thonny. This wizard will install Thonny for your account. Click Next. License agreement. I accept the agreement. That's what I'm going to install it to. That's what I'm going to call it. And yeah, I'll have a desktop icon. Why not? And great success. Thonny is now installed. Run it via the shortcut or right-click a Pi file and select Edit with Thonny. Okay. Finish. Plug the Pico into the breadboard. Right, let's get this plugged into this breadboard. Let's get it open. So what we're looking on here is we want to plug it in on the top here from C, from column C. And we want it the other way up. And then we'll just push into the breadboard and there we have it. Installed. Your Pico should be fully inserted so you can't see any of the metal legs pins. The black plastic on the underside of the Pico should sit flush with the top of the breadboard. Just like that. Apply strong pressure evenly on both ends. Now locate the little button on the top of your Pico. This is the boot cell button, which when held in whilst connecting the cable allows us to install different firmware to the Pico. That'd be this button here. Hold down that button whilst plugging in the USB cable into your computer's USB port at the same time. You may see it pop up as a new device on your computer, but just ignore that for now. Okay, let's get the USB cable. Plug it into the computer. So I'm going to hold the button in. I'm going to plug in the Raspberry Pi. And I've just got a notification that new hardware has been picked up by the computer. Here we go, all plugged in. What does it say do? So in Thonny, at the bottom right hand corner, you'll see something like MicroPython, Raspberry Pi, Pico, and a COM port, like the example below. This may vary, but it doesn't matter at this stage. Click on this and you'll see a few options. Select MicroPython. Install MicroPython. Target volume is the RPI RP2. The MicroPython variant, open bracket, speech marks. This is my Pico talking, speech and close bracket. And now click the Run Current Script. You should now see the following in the shell window. This is my Pico. Yes, we do. Excellent. Ah, yes, you did it. Your first program. A few things to note. Print text strings always sit within inverted commas within brackets. Letter case is very important with MicroPython and other code languages. Our print is always undercase print and never capital print. Now try changing the text between the inverted commas. You can write anything you want. This calendar is going to be awesome, or I don't like pineapple on pizza, or even the famous hello world. Welcome to my channel. So if I then run the script, excellent, welcome to my channel. Okay, so activity 2, light the onboard LED. We know where to write code in Thonny and how to run a program. We'll be doing a lot more of that over the coming days, so for now let's jump straight into a bit of Blinky. The Pico comes with a little LED on board which is attached to one of the Pico's RP2040 pins, GPIO 25. This pin isn't one of the physical pins available around the edge of the board. We can tell our program to turn this pin on and off whenever we like, which is a nice, easy first hardware project and can be handy as an indicator for your own projects later on. This is the beginning of getting your code to control physical things. Inputs and outputs. Our GPIO pins, the green ones from the pin map, can be set as inputs or outputs. We use inputs when we want something to send signal voltage into the Pico, like a button or a sensor, and we use outputs when we want the Pico to send signals, voltage out to something else like LEDs or buzzers. We're going to use an output here which will send voltage to the onboard LED to light it up. Imports. Take a quick glance at the first line of the example code below. When we write code in Thonny, a lot of the time we need to add imports at the start. Imports bring in code from other places that we need to make our program work. Usually these are built-in modules. To use the GPIO pins, we also need to import pin. The code. Take another look at the example below. So what is it doing? The first line imports pin from the machine module on the first line, which simply allows us to use the GPIO pins. The second line is setting up one of the pins to allow us to use it in our code. This sets up GPIO 25 with the name onboard LED. We use pin.out at the end there to tell the MicroPython to set this pin as an output. The third line then finally sets the pin value to 1, which is high on. 1 is always used for high on, and 0 is used for low off. So from machine, import pin, onboard LED equals pin 25, pin.out, and the value is 1 to be on. Okay. Copy that code to the top right panel and hit the run button. So copy. I'll get rid of what we had on there previously. I've pasted that in and then I'll click the run script. And when we run this, the LED comes on. Now let's try changing that to a 0 and run it again. And that turns it off. Let's change that to a 1 again. And that turns it on. Excellent. So well done, fellow maker. Today you have become an owner of your very own microcontroller, learned about the Raspberry Pi Pico, set up your Raspberry Pi Pico with Thonny, created your first program, learned about the print function, controlled a physical component with code. Now get some rest and a good night's sleep for tomorrow, and we'll continue the fun with day number 2. Excellent. That was fantastic. So there you have it, guys. That's us running a program on our microcontroller. Day number 1 complete. I'll see you tomorrow for day number 2. Ta for now.